Hey guys, so today we're going to go over evaluating the limit plus a brief algebra review. So when you evaluate the limit or you're determining the limit, your go-to should always be direct substitution, just because it's simple. Here for number one, the limit as x approaches 1 of x squared plus x minus 6. Um, Graphically, you would graph this parabola and you would look towards the left and right towards when x approaches 1 of what your limit would be. But another way around this is algebraically, you can use just direct substitution, so meaning I replace x squared with just 1 squared. Instead of plus x, it'll say plus 1 and then minus 6 and just bring that down. So you're directly substituting x for 1. And then bringing this down, this will give you 1 squared, which is 1 plus 1 minus 6. PEMDAS tells us adding and subtracting go from left to right. So 1 plus 1 is 2. 2 minus 6 is negative 4. So that's your limit. So direct substitution is usually a fan favorite. However, it doesn't always work initially. Meaning, if it doesn't work at first, it doesn't mean that there is no limit. It means that you may have to take an algebra approach first. So for instance here, and I'm going to rewrite the function a little bit just so you can kind of see it in fraction form a little clearer. So notice this is the limit as x approaches negative 3 of x squared plus x minus 6 all over x minus 3. If I were to do direct substitution, this would give me a denominator of 0 because negative 3 plus 3 is 0, so that would be the limit doesn't exist. However, that's not technically the answer. Sometimes there is an algebra approach. And then I'm going to note this disclaimer. If the algebra approach, you use it and direct substitution still doesn't work, then yeah, the limit won't exist. But you should at least try first. So in the numerator, I want to note that you cannot divide anything out unless you can factor it out. For instance, anything that has a plus or minus, you can't just divide out. Like this is not a thing. If it has a plus or minus sign, you have to be able to factor it out in order to divide it out. So for instance, like here, there's no GCF. There's nothing to factor. So there's no dividing out on this one. But that was just, a sidebar. For this actual question in the numerator, you can factor. Remember module 2. This is a quadratic, so multiply first times last, a times c. I need two numbers that multiply to be negative 6 and add up to be the middle number b, which is positive 1. So those two numbers are going to be 3 and negative 2. And over each number, you're going to put 1 and x, or you could just put x instead of 1x. And each one of these fractions represents your parentheses. This is just kind of a quick way to factor. If you go back to module 2, there is the tutorial on how to factor quadratic functions that goes into more detail. So each fraction represents each parenthesis. So this would be x plus 3. And the second fraction would read the second parentheses, which is x minus 2. And then I'm going to bring everything else down that I haven't used. This denominator of x plus 3 comes down. The limit comes down, which is the limit as x approaches negative 3. So from here, if you can factor it out, you can divide it out. So you got your x plus 3. That's the only thing in the denominator, x plus 3 in the numerator. It's factored, which means you can divide it out. Your new problem is now the limit as x approaches negative 3 of x minus 2. You no longer have that zero denominator problem, which means you can do direct substitution. So if I directly substitute in x as negative 3 minus 2 would give me negative 5, and that's my limit. And then just another brief tutorial on your algebra, just in case you forgot it. I'm going to bring this over just so you can read it a little clearer in fraction form. So the numerator can be factored. If you can recognize a difference of perfect squares, then you'll also know the shortcut to factor it. If you do not remember how to use the shortcut to factor a difference of perfect squares, then that's fine. You can rewrite x squared minus 1 as x squared. Remember, this is ax squared plus bx plus c. So since there's no bx, you can just write plus 0x and then minus 1. And you can factor just like we did in number 2, where you multiply first times last and go from there. But I'm going to use the shortcut. So if you have a difference, meaning subtraction of two perfect squares, meaning I could take the square root of each one of them perfectly, then that means that one parentheses will always say plus, the other will say minus, and I'll square root each one of them. The square root of x squared is x, so each parenthesis starts with x, and then the square root of 1 is 1. I'm not taking that minus sign because remember this is called a difference of perfect squares. So the minus sign has already been compensated for with that plus and minus. So difference of perfect squares. So yes, like I was saying, the square root of 1 is 1, so each parentheses will end with 1. And if you ever want to check your factoring, you can always FOIL, and it'll bring you right back up to what you had before, if you factored correctly. From here, I'm just going to bring everything else down. And again, if you can factor it out, you can divide it out. And now you're left with the limit as x approaches 1, sorry, I'm out of room here, of x plus 1. And now you no longer have a denominator, so you don't have the problem of a zero denominator again. You directly substitute 1 plus 1, which will equal to 2. All right, guys, brief algebra review, but hope this helps.